Imagine a single terrifying question: could a new weapon ignite the very atmosphere and end all life on Earth? In 1942, a group of brilliant minds gathered to unlock the energy inside the atom. As they worked, a chilling possibility emerged. Could their bomb start a chain reaction that would burn the air and oceans? For a moment, the fate of the world rested on a calculation. This is the story of J. Robert Oppenheimer, the man at the center of that decision. We'll witness the birth of the atomic age and the profound moral questions it raised. The fear of atmospheric ignition was real. Oppenheimer and his team paused, checking and rechecking their math. The immense heat of an atomic explosion, they theorized, might fuse nitrogen in the air, creating a global firestorm. Only when calculations showed this was impossible did the project move forward. But the question left a permanent mark. For the first time, humanity had to consider its own extinction as a result of its own invention. The scientists had looked into the abyss and stepped back, forever changed. The shadow of that question would loom over everything that followed. This is how science unlocked the power to destroy worlds, and how one man would be haunted by what he helped create. The story continues to shape our world today. The world held its breath, and then exhaled, barely. J. Robert Oppenheimer was a man of contrasts. Born in 1904 to a wealthy New York family, he was brilliant but emotionally fragile. He mastered languages, devoured science and literature, but struggled with loneliness and depression. At Harvard, he finished chemistry in 3 years, but his interests spanned physics, philosophy, and Eastern religions. He was clumsy in the lab, impatient with experiments, and once left a poisoned apple for a tutor, a sign of his inner turmoil. Oppenheimer was not just a scientist, he was a poet, philosopher, and mystic. He quoted Sanskrit as easily as quantum mechanics, seeing connections others missed. His anxieties and search for meaning shaped his path. Theoretical physics became his refuge, a world of pure thought where he could escape emotional chaos. Here he began to build his legacy, striving to reconcile the different parts of himself. Oppenheimer's complexity would define his leadership and his burden. He was a man seeking order in a universe of uncertainty. That search would lead him to an unimaginable crossroads. Oppenheimer's scientific turning point came in Germany at the University of Göttingen in 1926. Göttingen was the epicenter of the quantum revolution, where the old certainties of physics gave way to a world of probabilities. For Oppenheimer, this was a revelation. He had found his true calling. Surrounded by minds like Max Born and Werner Heisenberg, he thrived, publishing brilliant papers on quantum theory. His rapid, intuitive grasp of complex problems set him apart. Earning his doctorate at 23, he returned to the US as a leader in the new physics. At Berkeley and Caltech, he inspired students and built the first great American school of theoretical physics. Oppenheimer was no longer just a brilliant student. He was a leader, attracting the brightest young minds. He channeled his energy into building a community devoted to discovery. The spark ignited in Göttingen became a flame, one soon tasked with unlocking the most powerful fire on Earth. Oppenheimer's journey from awkward student to scientific leader was complete. The stage was set for a task of immense and terrible importance. To understand the atomic bomb, look inside the atom. At its core is the nucleus, protons and neutrons held by a powerful force. Some elements, like uranium, have unstable nuclei storing immense energy. The secret to releasing this energy is nuclear fission, splitting the nucleus. Fire a neutron at uranium and it splits, releasing energy and more neutrons. This triggers a chain reaction, like a room full of mousetraps set off by a single ping-pong ball. The reaction happens in a flash, unleashing staggering power. Control it and you get nuclear energy. Unleash it all at once and you get an atomic bomb. The Manhattan Project's challenge: create an instantaneous, uncontrolled chain reaction. They needed to assemble enough unstable material in just the right way to change the world forever. It was a scientific puzzle with the highest possible stakes. The power hidden in the atom would soon be unleashed. The consequences would be unimaginable. As World War II raged, the fear that Nazi Germany might build an atomic bomb drove the US to launch the Manhattan Project. This secret effort involved hundreds of thousands, but most had no idea what they were building. At its heart was a secret lab, tasked with designing the bomb itself. General Leslie Groves needed a scientific director, someone who could unite theory and practice. He chose J. Robert Oppenheimer, despite his lack of management experience and political baggage. Oppenheimer proposed a single, isolated site, Los Alamos, New Mexico. In months, a secret city rose from the desert, roads, labs, homes, all hidden behind barbed wire. Its address was a post office box in Santa Fe. Life at Los Alamos was intense. The world's greatest minds worked around the clock, driven by fear the enemy was ahead. Oppenheimer became the project's center, guiding and inspiring his team. The thin, troubled academic transformed into a decisive leader. Los Alamos was a city dedicated to a single terrible purpose: building a weapon to end the war. The stakes could not have been higher. The world's fate was being decided in a place that officially did not exist. The countdown to the atomic age had begun. The scientists at Los Alamos faced a monumental challenge: how to assemble uranium or plutonium into a working bomb. The key was creating a critical mass, enough material to sustain a chain reaction. Two designs emerged. The first, the gun-type bomb, used two pieces of uranium. One was fired into the other, forming a critical mass and triggering the explosion. This design, later called Little Boy, was considered reliable. The second, for plutonium, was far more complex. Plutonium couldn't be used in a gun-type device. It would detonate too early. The solution: the implosion design. A plutonium core was surrounded by explosives which, when detonated, created a symmetrical shockwave, compressing the core to critical density. The timing had to be perfect. Any flaw and the bomb would fail. Oppenheimer dedicated vast resources to solving this engineering puzzle. The implosion bomb, called Fat Man, was a huge gamble. Success would mean unlocking a new level of destructive power. The fate of the Manhattan Project, and perhaps the world, rested on these two designs. The race to build the bomb was reaching its climax. By summer 1945, the implosion bomb was ready for its ultimate test. The gun-type bomb was so certain to work it didn't need testing. But the implosion device was full of uncertainties. A remote desert site in New Mexico was chosen: Trinity. The bomb was hoisted atop a steel tower. Scientists watched from miles away, tension thick in the air. Oppenheimer, chain-smoking and anxious, paced as the countdown began. At 5:29 a.m. on July 16, 1945, the bomb detonated. A blinding flash lit the desert, followed by a wave of heat and a deafening roar. A fireball rose, forming the now iconic mushroom cloud. The steel tower vanished, vaporized. The scientists felt awe, relief, and horror. The bomb had worked. Their gamble had paid off. Oppenheimer recalled a line from the Bhagavad Gita. "Now I am become death, the destroyer of worlds." The atomic age had dawned, magnificent and terrifying. The world was changed forever, and Oppenheimer knew it instantly. The power to destroy had been unleashed. With the Trinity test a success, the decision to use the bomb fell to political leaders. Germany had surrendered, but the war with Japan raged on. President Truman saw the bomb as a way to end the war quickly and save lives. On August 6, 1945, the Enola Gay dropped Little Boy on Hiroshima. The city was flattened. Tens of thousands died instantly, many more from burns and radiation. Despite the devastation, Japan did not surrender. 3 days later, Fat Man was dropped on Nagasaki, killing tens of thousands more. Faced with unimaginable destruction, Japan surrendered on August 15th. The war was over, but a new era of fear had begun. Humanity now knew it could destroy itself. Relief at war's end was mixed with dread about the future. For Oppenheimer and his team, the news was devastating. They had hoped the bomb would never be used on a city. The images of destruction left them with guilt and responsibility. After the war, Oppenheimer became a symbol of scientific genius and its burdens. Hailed as the father of the atomic bomb, he was haunted by its consequences. He told President Truman, "I feel I have blood on my hands." Oppenheimer advocated for international control of nuclear weapons, warning of an arms race. His warnings went unheeded. The Cold War began, and the Soviets tested their own bomb. The push for even more powerful weapons, the hydrogen bomb, followed. Oppenheimer opposed it, calling it a weapon of genocide. His stance made him enemies. During the McCarthy era, his security clearance was revoked. Cast out from government, he spent his remaining years in academic exile. Oppenheimer's story is a cautionary tale about genius and responsibility. He unlocked the secrets of the universe, but could not control their use. His creation ended a war, but cast a permanent shadow over humanity. With great power, he learned, must come profound wisdom and moral duty. As we look back on the legacy of Oppenheimer and the world forever changed, the story doesn't end here. History is full of untold moments, brilliant minds, and lessons that shape our future. If you want to explore more incredible stories and the people behind them, make sure to hit that subscribe button now. Animated subscribe template appears. A glowing red button pulses, a hand icon clicks it, and confetti bursts around the screen. Dynamic arrows and text animate in. Don't miss out! Join our community. Join thousands of curious minds. Turn on notifications so you never miss a moment of history that matters. Thanks for watching. Your journey through the past is just beginning.